Neelam, can you just check? I will just share the screen one time. You can just check whether you're able to see.
Okay, I've started the webinar actually.
Okay, maybe
So
we'll do it
if you
later.
want to check it, you can check because we have 1 minute to start.
Yeah, just a minute. Can you see the presentation?
Yes, I can see it.
Yeah, sure, sure. Then it's fine. Yeah,
Okay.
yeah. Thank you.
Hi, Sriram. Hi, Neelam.
Hi,
Hi.
Anand.
Anand, you can also mute yourself.
Yeah, I'm not on mute.
You will, acha, correct. Yes. So good evening, everyone, and a warm welcome to ICE platform. I'm Neelam Parshuram from IC Ventus team, and thank you for joining us today. For those who are attending this for the first time, welcome to our weekly webinar series where every Tuesday we connect with professionals, experts, and learners from elevators and escalator industry on one common platform. While we wait for a few more participants to join in, I'll take few minutes to explain what does IC do and how do we work with the industry. Hope my screen is visible. So ICE platform is designed to share practical knowledge, industry insights, and real world experience that can help you grow professionally and stay updated with the latest developments in the industry. We are glad to see participants joining in from different locations, and we truly appreciate you taking time out of your busy schedule to learn, to gain insights, and upgrade your knowledge with us today. So it is an initiative by IC Ventus. IC Ventus also organizes exhibitions, trade shows, and industry events. We create a platform that supports learning, collaboration, and business growth. IC Ventus have become a trusted bridge connecting regional markets with global opportunities. Our upcoming shows, first is IC India 2026, will be held on 3rd, 4th, and 5th December in Delhi, proudly making the capital city the host of this year's edition. With strong support, ICE has grown to become the fourth largest exhibition of elevators and escalators, reflecting the trust collaboration of the entire industry. This year's expo is planned across a massive area of 40,000 square meter, featuring around 350 plus exhibitors, making it one of the largest gathering of vertical transportation industry in India. So get ready and plan your visit accordingly. We recommend you to at least plan for 2 days visit to experience the scale of this expo. Our next show is I see the Monsoon edition in Chennai, featuring the quiz, symposium, and a dynamic industry expo scheduled for August 5th, 6th, and 7th, 2027. The monsoon edition reflects the Chennai's regional weather calendar held before the monsoon season. It creates a perfect time for the industrial professionals to network and to plan the upcoming project and discuss solutions before the operation slowdowns, typically caused by heavy rains. I see our next show is I see Africa 2027 will be held from 24th, 25th, and 26th November at KICC Nairobi. As you may know, Kenya is emerging as one of the fastest growing markets in Africa for infrastructure and urban development, creating significant opportunities for the elevator and escalator industry. In this context, IC Africa 2027 will bring together global manufacturers, suppliers, and industry leaders to showcase safe, innovative, and sustainable vertical mobility solutions and drive growth across Africa's vertical mobility transportation sector. IC papers. So vertical transportation industry has always been built on knowledge shaped by experience, innovation, and real world challenges. Yet much of this knowledge often remains scattered, undocumented, and limited to individuals and organizations. That's why IC Papers is created, a platform designed to bring industry closer together. It is a space where you can share knowledge, showcase your professional journey, and even highlight your interest beyond work. It also helps you to connect with professionals across the industry and learn more about the people you work with. In addition, IC papers will feature about your company profile, research articles, industry insights, and updates on events happening in the vertical transportation sector. This platform is built by the industry and for the industry to encourage learning, collaboration, and growth. If you are part of the vertical transportation ecosystem, this platform is for you. So please do visit the website icpapers.com, and you can also follow us on social media as well. Moving on to our today's session, we are pleased to have with us Mr. Sri Ram Rangarajan, Project and Application Engineer at Brug Lifting, and Mr. Anand Ganji, Head of System Engineering at Brug Lifting. Together, they bring a deep expertise in traction elevator systems, system engineering, and innovative suspension technologies. Today's session is on from conventional steel ropes to high performance polymer coated traction means the journey of traction elevator systems. We will explore the evolution of traction elevators and how modern traction means are driving improvements in efficiency, ride comfort, and next generation elevator performance. Also, we are pleased to share that Brug Lifting will be participating in IC 2026, and you can connect with them at booth number IF51 during the exhibition. A quick note to the audience, please feel free to put your questions in the chat box during the session. We will take up these questions at the end during Q&A round. With that, I invite our speakers to take over.
Cool. Thank you so much, Neelam. I hope I'm audible, right?
Yes, you are audible.
Okay. So let me also come in front of my video. So I hope everyone can see us. Sriram, I would request you if you could share the screen, the presentation that we will be presenting.
Yes, I will share.
Yeah. So thank you so much, Neelam, for the introduction. And I welcome once again everyone whoever has shown interest towards this presentation. So here we are talking about the journey of traction elevators from conventional steel ropes to highly performing, the polymer coated means. So this is something that we already presented at ISEE symposium that we had recently in Chennai. And it would be a recap, and we would be very keen to to understand how much curiosity that it has really created. So, okay, as soon as Sriram shares the screen, we would start
Can you
with our
see, Anand?
presentation. Yes, I can see the screen.
Yeah. Yeah, fine.
Neelam, you'll have to confirm. I can see the presentation, so I'm not sure if it's visible to everyone. So if you could
Yes, it is
confirm that.
visible. Only thing, can you click on that hide thing
Yeah,
that
sure, sure.
shops? Good. Now it's visible.
Okay, so as I said, the topic we're going to present today is the journey of traction elevators from conventional steel ropes to highly, performance polymer coated traction means. So that's the topic. And myself, Anand, and Sriram, my colleague, is actually Dr. Sriram. So we both are going to present this. And before we start our presentation, so we both come from the company called Brook Lifting. It's a Swiss-based company. So it's been there in the industry from last 120 plus years. So we are very popular in Europe and US markets when it comes to elevator industry. We are well known when it comes to elevator ropes. And very soon we would also be operating from India. And just to let you know, everyone, that we are the first foreign manufacturer who could get the BS license because this elevator ropes, the standard IS 2365 has become part of the QCO. As part of that, we must have the license to be able to use it in the Indian market or to be able to actually export from our Swiss plant. So we were the first foreign manufacturer to receive it, to receive the BS license, and it is effective from December 31st, 2025. So with that quick intro, so I'll jump into the presentation. So so here you can see the overview of the presentation. So we're gonna have a short introduction of this topic, and we are gonna see what are the different types of suspension media and how exactly the suspension media is, helping to optimize the elevator performance and the advantages and installation requirements of the suspension means, and some simulation results that Sriram has extensively worked on, and we're going to see the conclusion of the topic. So to start with, as you all know, there is a high emphasis on energy efficiency, the space efficiency, and higher lifetime for elevator systems. Not just from the elevator manufacturers, even from there's more awareness that's coming from the customers and from the builders and the actual residents who would be using this elevator. So, and this suspension media is going to play a key or critical role in achieving these objectives, like in terms of the energy efficiency, the space efficiency, and the higher lifetime of an elevator system. So here, what you see is like basically what are the different types of suspension media we have. On the left side, what you see is the conventional steel ropes, what you typically see. And here, the topic is about shifting from this conventional steel ropes to the coated traction products. So under the coated traction products, like we have two products. One is the belt. Probably many of you must be familiar with it, and this coated ropes, which is not so popular in India, but this is also something is coming under this coated traction product. So what do we mean by coated traction product? It's basically for the coated rope, it's basically a steel rope itself. It is enclosed in a polymer jacket, and the belt is also a steel cords enclosed in the polymer jacket. We can move on to the next slide. So here you would see how actually the suspension media can optimize the elevator performance. So you can look at the 2-to-1 typical elevator layout here. So basically, the traction shield that would also be a very important aspect to consider the space that you require for the elevator. So this traction shield diameter is basically decided by the type of suspension media that we are using. Yeah. So what are the advantages? Maybe we are directly jumping into this topic of like what are the advantages with the coated traction products. So as I said in the previous slide, the diameter of the traction sheave is basically decided by the suspension means that we are using. So when you use the coated traction rope, we can go as low as the traction sheave that is 25 times the diameter of the steel rope we have inside the polymer jacket. So in case of the belts, it's like 40 times the diameter of the steel cord that we have inside the polymer jacket. So it means like if you take a typical rope of 8 mm, 40 times the diameter of the rope is what should be the diameter of your traction sheave. So it means like it's 40 times 8. It's 320 mm should be your diameter of the traction sheave. Whereas if we go with our maybe in the next slide we'll talk about like 8.1 diameter is the typical rope that we have, the coated traction product. Maybe Sriram, we can go to the next topic, next slide, where we mentioned like what is the. So if we have the 8.1 CTP rope that is that's more popular in the Europe market. That's actually when we compare with 8 diameter. So the diameter of the traction sheave is actually 50 times less, and when we compare it with the traction sheave that is required for the 53 kilonewton belt, it's like 68.75% less diameter is what you require when compared to 8 the steel rope that we see. So that itself tells you like how much space that you can save in terms of the overall space that you require for a given elevator configuration. And apart from this, the space saving that you can do with reducing the diameter of the traction sheave, we also see the high traction capability, because the coefficient of friction here, the interface or the contact between the suspension means and the traction sheave is actually between the steel and the polymer, the material that we are using. Whereas in case of typical steel ropes, it's always like steel to steel contact. So because of this interaction between the steel and the polymer coating, the coefficient of friction between these two is very high, and that would give you a better traction capability. And this would help to reduce basically the cabin weight, or uh, yeah, I mean this in a for a given passenger capacity, you can have the smallest, light cabin weight, which would accommodate the same passenger capacity that you would like to have. So maybe Sriram, from here, from the traction calculation onwards, you can take over.
Yes, sure. Can you hear me?
Yes, you can.
Yeah. And thanks, Anand, for the nice introduction about the coated traction products. And now let's dive a little deeper. Let's try to understand the technical aspects of the coated traction products and what is the difference in terms of technicalities between a conventional steel rope and the coated traction products. For example, whenever we select any traction media, the first thing that we have to ensure is that how much traction it gives and whether that traction is sufficient enough or not. I mean, there are certain conditions in which you need to have the suspension media to slip, and there are certain conditions in which it should not slip. So the standards have defined that, and we need to ensure that we follow that. Here, I mean, we are just trying to show an example. Let's say you take a system of the payload 400 kg. We have shown here. You can see here the payload as 400 kg and the empty cabin as 750 kg. And if you assume a balance factor of 50%, your counterweight will be 950 kg, and 2:1 system with a height of 25 meter and safety factor as 12. So you need to have 3 ropes, and this is like a typical low rise, low duty elevators, residential elevator system. Now when we do the traction calculations, we try to compute the tension ratio T1 by T2, T1 for the car side and T2 for the counterweight side. And we have to ensure that even at 125% of the payload, we need to ensure that the track suspension media doesn't slip. So if you see, T1 by T2 ratio is fixed once we fix this system, once the payloads and everything is fixed. Now, if I go for a conventional steel rope with the U groove, the coefficient of friction is only 0.09. The standards have defined it. And as per this, if I calculate the traction, inequality formula, we call it as Euler's formula. If you go with E power F into alpha, where alpha is your wrap angle and F is nothing but your friction coefficient or a friction factor, what you get for a conventional rope is 1.327, but whereas what we need is 1.355. So certainly a conventional rope with the U groove is not going to satisfy. But if I go for a CTP, which is a coated traction product. It could be a rope or it could be a belt because, as Anand told, in CTP you have two categories. One is rope and another is belt. And due to that polymer coating that you have, naturally you get a higher coefficient of friction, which is like 0.25. You can see that conventional rope is just 0.09, but here, even with U groove, I get 0.25. So easily I'm able to satisfy the traction condition. So you can very well see that, even if I try to reduce my cabin weight, I can still ensure that I get enough traction. So that's the advantage that you can have for the same payload. You can try to have a lighter cabin. So if you have a lighter cabin, then if in terms of accelerating torque of the motor, it comes down. Shaft load of the motor can be brought down. So these are the advantages that you may get. And uh, and another thing, this is the main reason why a conventional rope, you cannot have a U groove. Either you have to go for a V groove or you have to go for an undercut U groove. So to get the higher traction, or if you use a U groove, what we say, you need to have a double wrap. So these things, I mean, generally complicates, and it also brings down the lifetime of the rope. But with the coated traction product, since inherently we are getting a higher coefficient of friction, you can simply have a U groove. And so we will come to that. But this is a traction calculation which we have taken, a typical low rise elevator, residential elevator system, just to show that just with the CTP you will be able to satisfy the traction, but whereas with the conventional rope you need to have some kind of an additional uh, you know complexity, either a change of the groove shape or double wrap or something to satisfy the traction. And another advantage is, like as Anand mentioned, when you talk about the coated traction product, it's like you have a polymer coating outside and that's going to interact with the groove, which is a steel. So it's not a steel to steel contact. What you are going to have is a polymer to steel contact. But conventional rope is steel to steel. So generally, you face a noise issues due to this steel to steel interaction. But with the coated traction product, due to the fact that your polymer is interacting with the steel, the noise level comes down. And also, this polymer coating, it provides additional damping to the system, and which may become an important factor when you talk about vibrations, when you talk about noise. Because, for example, if you have a resonance that you want to avoid, so these polymer coating is really going to help you because it provides additional damping. And just to show that, and what we have done is that generally what we do is, like with all our ropes, we derive a frequency response plot to see where the natural frequencies or the resonant frequencies of the system. For example, this HRS is our full steel core rope, DP9 is our mixed core rope, 8 by 19 is our fiber core rope, and coated traction rope and coated traction belt. So here we have just, let's not go too deep into it. Basically, what we do, we derive a frequency response plot that shows the frequency, magnitude with respect to frequency, and phase with respect to frequency. And for the same system, we derive with the different suspension media. And you can clearly see that when you change the suspension media, your frequencies, basically these peaks that you are seeing, the peak and the valleys that we call it as natural frequencies or the resonance and anti-resonance frequencies, that changes. So a change of the suspension media has an impact on your natural frequencies of the system. And as the elevator travels from the ground floor to the top floor, these frequencies keep shifting because the length of the rope changes. So what really happens is, like when you are going to have these kind of natural frequencies in the system, when you design a system, we try to generally avoid these frequencies. I mean, if you have worked on the system design and configuration, or if you are from the drive side, control side, we always try to ensure that we don't operate near these frequencies because we want to avoid the resonance. And in the coated traction product, since you have this inherent damping, so due to that polymer coating, which may provide that additional damping, which is absent with our conventional steel rope, generally the ride comfort is expected to be better. And we have also seen that the ride comfort of the coated traction products is, the elevator with the coated traction product, the ride comfort is better compared to the conventional steel ropes. And one more thing, what we would like to point out here is that we are not saying that the coated traction products are a replacement for the conventional rope. Not at all. It's not like a replacement. It is just that, I mean, if you see just few decades back, let's say 2 3 decades back, you just had only conventional rope, so you had to go with that. But now we have different types of suspension media. So when you take any elevator application, we can really try to optimize and then select the correct suspension media, which will give you a better energy efficiency, better ride comfort. It will also reduce your cost. It will also bring down the maintenance. So the total cost of ownership significantly comes down if you select the right suspension media, because nowadays you have a lot of suspension media. You can see here itself we have shown 5 types. So when you talk about an elevator, let's say a typical elevator, I mean, which suspension media to select, you always have a choice. And you can try to look at the performance and you can try to select the optimum suspension media so that you get a better performance, and at the same time you can also optimize your cost. So that's the purpose of showing this. It's not like we are trying to say that the coated traction products are a replacement for conventional, nothing like that. The conventional ropes, they have their own advantages in their specific application segment, but coated traction products, they have their own advantages in that specific segment. So we need to be really careful in selecting the suspension media. So that's the purpose of showing these plots. And another is, like, as I told, since you are able to get a higher traction inherently from the coated traction products, you can just use a U groove. You don't need to have a V groove, which you need to have with a conventional rope. Now, what's the advantage? The lifetime of the suspension media increases. Let's say when you design an elevator, you want an elevator to come for at least 15, 20 years. But you can always see that the rope may fail in 6 years, 7 years. And it's always replacing the rope is a cumbersome, time-consuming process. The elevator has to be put out of service, and it's always a problem with the customers when the elevator is out of service. So we always want the suspension media to come as long as possible. The lifetime should be better. So to do that, if you try to go for a U groove, it's better for the suspension media, because you can see here on the right side we have shown the U groove. The groove pressure on the rope, on the outer strands of the rope, is less if you have a U groove. It's a round groove. But if you have a V groove or undercut U groove, you will have these pressure points because it just touches at one particular point, which puts the pressure on the outer strands. So generally, as the elevator keeps running, this additional groove pressure brings down the lifetime of the rope. So that's also an advantage with the coated traction product. Since we just use only U groove, you can have a better lifetime. And we have shown an example here. This SCX is our conventional full steel core rope. Let's say we take that. That's a conventional rope, full steel core, 8 mm. And as per the standard, you should have 40 times the diameter of the rope. So 40 into 8, 320 should be your traction sheave diameter. But if I go for a 8.1 mm CTP rope, and I can reduce my diameter to 160, and if I go for a belt, I can bring it down to 100. This is because of the fact the standards allow you to go 25 times of the steel. And in the coated traction product, though the diameter is 8.1 mm, if you exclude the coating, the diameter of the steel cable is just going to be around 6.4 to 6.5. So we just take that and we'll have to just multiply 25, and we can reduce the traction sheave diameter. And when you talk about the belt, the cords inside the belt, the steel cords, they are just around 2 mm. So 40 times of 2 mm is around 80 mm. But generally, to have a better life, though we can go up to 80 mm, but we keep it as 100 mm. So you can see clearly there is a big difference in the traction sheave diameter, which means for the same payload, the torque rating of the motor is going to come down, because torque is nothing but the cross product of force into the radius of the traction sheave. So when the diameter decreases, your radius is also going to decrease. So the torque rating comes down, which means the size of the motor comes down, the initial cost of the motor comes down. So you will have a better energy efficiency, you will have a compact motor. So that's the first column where we are showing the difference in the diameter. And also when you talk about the life, how many bending cycles, because the rope has to bend through the sheave, it has to bend through the deflector sheaves. So how many bending cycles it can go, you can see that the full steel core rope, it can go up to 2.4 million cycles, but with CTP rope, it's almost twice. You can go up to 4.8 million. With belt, you can go even up to 10 million. So the service life, if the conventional rope comes for 4 years, you can expect the CTP rope to come for 8 years, and the belt, it can even come for 15 years. So you can see that, once you install, let's say, a belt, it comes throughout the lifetime of the elevator. not only that you are getting an energy efficiency and space efficiency, but also you are ensuring that you don't need to do any replacement, which is also going to bring down your total cost of ownership. Yeah. Now, another advantage is like in addition to the energy efficiency that you're going to get by reducing the traction sheave diameter, another advantage is that let's say for the same hoist way, you will be able to increase the size of the cabin because if you use a conventional steel rope, let's say we use a 10 rope, 40 times you need to have a traction sheave diameter of 400 but if I just go for a quarter traction product, I can just bring down to 50% of it. So I can have a 200 traction sheave diameter. So you are getting this additional 200 though the hoistway is same, but just by reducing the traction sheave diameter, I am getting this additional 200 which means that I can use, if I optimize it intelligently, I can use it to increase the cab floor space, which means you can accommodate more passengers. So, for example, if you use a conventional rope which can hold 9 passengers, a CTP rope based elevator can hold more passengers, maybe around 12 passengers it can hold due to the fact that you can have a larger cabin space. And also, I mean, another um, cumbersome thing with the conventional rope, especially with the fiber core rope, is like you need to have a periodic lubrication. But with the coated traction products, that need for periodic lubrication is eliminated. So this will also bring down your maintenance. Not only that, it also keeps the hoistway clean. Sometimes we have heard in some of the expositions that there were complaints that if you use the fiber core rope, um, let's say for high speeds, the lubrication starts coming out and it makes the hoistway dirty. It makes the sheave dirty. It makes the groove dirty, and it also affects the friction. Traction comes down. But with the coated traction products, you will not have any of this problem because you don't need to have this periodic lubrication. So you will have a smooth operation once you install it. And sustainability, when we talk about sustainability, means in terms of the production, not really from the operation of the elevator. Let's say I have to produce a full steel core rope, I have to produce a CTP rope, I have to produce a belt. Now the CO2 emissions that comes due to this production is like with the steel core rope you have a significant CO2 emissions, but with CTP rope it comes down, and with CTP belt you can further bring it down. And of course, if you try to have recycling and if you try to use renewable energy and all, you can further significantly bring down your CO2 emissions. This also aids you in ensuring that even right from the beginning of the rope till the usage of the elevator, that overall CO2 emission comes down, which means it contributes towards the sustainability, because nowadays the government regulations are forcing towards sustainability due to the greenhouse gas effect, due to this global warming and everything. So we need to ensure that no, the every component that we use in the elevator, it contributes towards the sustainability. And in that aspect, compared to your conventional steel core rope, your CTP rope and CTP belt performs better. And of course, engineering teaches us that you can't get everything. It's not like you can always keep having only the advantages. Now what is the pain point, we need to we have to equally understand that as well, because to exploit all the advantages that we have mentioned so far, you need to ensure that how to install these coated traction ropes. It's not like a conventional rope. We have enough experience, the market is quite mature. But when you talk about the coated traction rope, well, since you have that polymer coating outside, you have to be really careful while installing this coated traction rope. And these coated traction products are sensitive to lubricants, fats, oils, and similar substances. So your hoistway has to be really clean. There should be no moisture contact with the CTP. And the fleet angle, which is the angle like between the traction sheave and the rope when it comes out of the traction sheave, that has to be less than plus or minus 0.5 degree. Otherwise, what may really happen, an excess fleet angle may really rupture this polymer coating, and your sheave geometry and properties of the sheave should meet the specifications specified by the manufacturer. For example, the roughness of the traction sheave. So let's say you take our belt, we specify that this has to be the roughness of the traction sheave. So you have to ensure that that roughness is maintained. Otherwise, you don't really get that performance. Sometimes you may start facing some noise issues, because not because of the fact that belt is creating the noise. It's just because of the fact that the sheave that was being used is not really compatible with the rope, with the belt or the coated traction rope that is being used. So always you need to look at the manufacturer what he really specifies for the traction sheave in terms of geometry, in terms of roughness, in terms. So we have to ensure that we maintain that, and we need to ensure there should be no twist. The rope should be untwisted both before and during installation, and you cannot allow any reverse bending of the rope because again this will damage the polymer coating. Now coming to the simulation, I mean, why we have done this simulation is just to show how much reduction in the current rating you can get, because we mentioned that you can bring down the torque of the motor, but what's the advantage in bringing down the torque of the motor? The cost of the motor comes down because you need to have less current in the motor, which means the coil that has to be used, the conductors that has to be used have to be rated for less current. So that's where you get the advantage with respect to reducing the size and also this cost in the initial cost. And to show that comparison, we have just done a simulation. Let's say you take a payload of 907 kg passenger capacity and an empty cabin of 1360 kg, and let's assume a safety factor of 12 because that's a common. And if we take a balance factor as 50%, let us consider this system, and use a conventional rope which is 8 fiber core rope that's quite popular in India, and let us try to take the same system and replace the fiber core rope, 8 fiber core rope with the CTP rope, 8.1 diameter rope, and also let's see with the CTP belt, 53 kilonewton belt. All these three are from Brook. It's a Brooks fiber core rope, Brooks CTP rope, and Brooks CTP belt. So we have taken that as a reference to compare. So with the conventional rope, you can see that when the elevator is accelerating, it goes even up to 24 ampere, the peak current. And then, of course, when the elevator starts operating at the rated speed, it comes down. It's around 12 to 13 ampere with the conventional rope. Now, with the CTP rope, you can see that the peak current itself has come down to around 12 ampere, and the rated current, current at the when the elevator is operating at the rated speed, which we call it as the rated current with the rated torque as well, it comes down to around 6 to 7 ampere. And if you go for a CTP belt, you can further bring it down. And here we have shown the comparison table. Conventional rope, you need a motor torque, peak torque of 700 Newton meter. With CTP rope, you can bring it down to 370 Newton meter. With CTP belt, you can further bring it down to 250 Newton meter. And here we have also shown the peak current rating that you need. So not only the motor has to take these currents, even the drive that you are going to use, that also has to be sized for these currents. So if you reduce the current rating of the motor, the drive rating also comes down. So that's another advantage which you are going to get. And as we mentioned, with the CTP, you can increase the size of the cabin. So let's say with the conventional rope, you need 4 elevators to handle 48 passengers in a building. Let's say in a building, you need to handle 48 passengers. You need to have 4 elevators with 13 passengers per elevator. But with the conventional CTP, since each elevator can handle additional passengers now, you can see that you can bring down the cost of one elevator completely. You can eliminate one elevator completely. So not only the energy consumption of each elevator is coming down, you can also, if you intelligently optimize the number of elevators in the building, you can also bring down the number of elevators. You can just eliminate the cost of one complete elevator system. So we have also shown the energy consumption per year, assuming let's say you have a 30,000 trips at full load. So we have shown how much energy savings you can get. And coming to the conclusion, and the Indian elevator market is growing. In fact, compared to Europe and US, the new installations are increasing in India. Even the China market has saturated in terms of new installations, but India, the new installations are picking up. So this is the right time for us to really understand the technicalities of the suspension media, because the suspension media plays a most critical role in ensuring the lifetime of the elevator system, in ensuring ride comfort, in ensuring energy efficiency, space efficiency, sustainability. The suspension media contributes towards everything. And even the government regulations and industry standards, they're increasingly emphasizing clean energy and sustainability. And if you see, especially in cities like Mumbai, Delhi, Bangalore, the high-rise buildings are coming up, and elevator is not no longer a comfort. It's a necessity right now in a building. So they are becoming a major energy consumers for the electricity grid. So we need to have an elevator system which is green, which consumes less energy. And also, the motor that we use in an elevator system, generally they are permanent magnet synchronous motor, and we know pretty well that in India we don't get the permanent magnets, so we have to depend on China for the permanent magnets because they are rare earth elements. So it's equivalently important to reduce the size of the motor as much as possible so that the dependence on the rare earth elements for the traction motor comes down. Otherwise, because it's becoming a significant concern. And here we try to show that how a coated traction product can help in achieving all these objectives. And the Brugg lifting being a major player across the globe in US and Europe, and so far in India, we don't have a footprint, but we have registered our company and we are soon going to have our footprint in India. You can expect us in by the end of this year or mostly early next year. Brugg lifting India will be established, and we will start producing the products in India. It will be a make in India product. So we'll have a local presence. So we are ideally positioned to, supply these products, whether it's a conventional rope or it is a coated traction rope. And we are also ready to work with the customers in doing these kind of frequency analysis, vibration analysis, and the lifetime calculations. So we provide these services as well in addition to supplying the ropes. Globally we also provide these kind of services, and which we are planning to do even for the Indian elevator market. And this is the plan as of now. Uh, and also, we currently we cannot exactly tell that what are the products that we are going to produce in India. But of course, depending on the demand, depending on the customer interest, we are always open, and we are always ready to include any product which has a demand in India. So, and if you have any question, thanks for your time. And if you have any questions, we can discuss.
Thank you, Sriram and Ananda, for the informative presentation. And it's a good news that about Brugg lifting that they are launching in India. All the very best for that. Now we will open the floor for questions from the audience. There is one question from Satyam, Mr. Satyam. Please show cost comparison.
Cost, here we have not included the cost. Cost, you're talking about the cost of the only the suspension media, or it's like you're talking about the total cost, because the cost of the motor also comes down, and it's like the lifetime increases. So I think ideally we have to look at the total cost of ownership, not only at the initial cost. So here we are not showing that calculation. But of course, we can share that we have that internally. We have done a total cost of ownership analysis for a given elevator system. And maybe, here I don't have that exact number right now.
Maybe they can he can connect with you later
Exactly.
to
Yeah,
discuss
yeah,
this.
yeah.
Great.
Exactly. That's what I would recommend, because this cost comparison cannot be a single number. It varies from configuration to configuration. There are different parameters that would come into the play: the passenger capacity, the travel speed, then travel height, and basically the configuration for which we are doing this comparison. So it's not a straightforward number that we can share. But if you're looking for any specific, elevator scenarios where you'd like, you're free to contact us, and then we can discuss furthermore.
Because let's say, if you take a conventional rope, let's say it comes for 5 6 years, and after that you have to replace. So there is a replacement cost. You have to buy the rope again. But that cost also comes into the picture. So we just can't look only at the initial cost. You have a replacement cost, and then you have the downtime cost and everything. But here it comes for 10 to 15 years. So we look at the total cost of ownership, and we have analysis to show this, and we will be happy to share that.
Maybe you can share your contact details with them
Yeah,
so
sure.
that they can connect with you.
Yeah.
Uh, can we move to next question?
I think I didn't
Next
turn on
question
my
is
video.
from
Sorry.
Mr. David Ball. how sensitive to amend the shaft dust and operational contamination in the coated product compared to alternatives.
So as we mentioned, I mean, coated products are highly sensitive to these kind of contaminants. You need to ensure that the hoistway is really clean, unlike your conventional rope, which are quite forgiving for these kind of things. But with conventional rope, you need to ensure that it is free from these kind of contaminants, and as much as possible, the hoistway has to be clean.
Our next question is from Mr. Samuel. What is the maximum travel limitation of the coated rope?
Yeah, this is a good question. The coated belt can even go up to 150, 100 to 150 meter, but the coated rope, as of now, we are restricting it to 40 to 50 meter. But we also have plans. We are working on further, increasing, developing a coated rope even for higher travel heights. But as of now, in the Europe market, we are providing. Our existing customers are using the coated traction rope up to 40 to 50 meter. And I think even Indian market, I mean, the average height, travel height is around 40 to 50 meter, and the coated rope suits well for those kind of scenarios. But we do have plans to have a coated rope even for higher travel heights.
Shall we move to next question? Next question is anonymous. Till what speed can we use belt coated rope? That's the
Yes. I mean, up to 5 meter per second, our coated ropes are certified rope speed. Rope speed is 5 meter per second. So for a 2:1 suspension system, you can have a cabin speed of 2.5 meter per second. So up to a 2.5 meter per second cabin speed, you can use the coated ropes, and we didn't see any problem so far. So our coated ropes are certified up to 5 meter per second, and even the coated belt is also certified around that 5 to 6 meter per second. So you can have a cabin speed, elevator speed of 2.5 meter per second max.
next question is from Mr. Bharat Kumar. Bharat Kumar. Bharat. Not only a rough finish, uh, shave had what is the SHEAVE? What is how to spell that? How to
Sheave.
pronounce
Yes,
sheave?
it's sheave. Yeah.
Yes, not only rough finish, sheave hardness also to be revised.
Means what is the question?
Not only rough finish, sheave hardness also to be reviewed.
I mean, is he asking that do we need to do we need to change the sheave hardness, or I mean, or it's
Acha,
like
there is more questions from him.
okay,
Increasing COF
yeah,
will reduce the sheave life.
sheave life. No, so no, I mean, so far we have not faced any of those problems where the additional COF reduces the sheave life. We have not heard those kind of
The way it
claims.
works is, maybe I'll answer this question, Sriram. So the way it works is you would choose the kind of a roughness of the surface finish that you would like to have for the belt that is going to be used for a particular application, and the material you would choose depending on the load that that particular traction sheave is going to have. So the static load is defined and the material is chosen accordingly, and the surface finish on top of the sheave is decided based on the traction, the suspension media that you're using. So this is how it works. Everything is considered in the design, and that's how the sheave life is going to be decided. Sorry, I mean, the question is not clearly understood, but I've just given a general way of how the design works. You would decide the sheave surface to match it with your belt that you want to use, or the coated product that you want to use, and the material that you choose to give the life that you're expecting, or based on the loading conditions of that particular configuration. That's how it is.
There is one more question from Mr. Bharatan Kumar. How to monitor, monitor or inspect the rope strand as it is covered?
Yeah, this is a very good question. Yeah, excellent question. So, yeah, this is a major challenge when you compare the conventional rope with the coated traction rope, because the conventional rope you can see any damages, but in the traction rope, since you have the polymer coating, you can't really see what is happening inside in the steel cable and the strands. So you need to have a condition monitoring device, and the most simplistic or rudimentary device is like generally any coated traction system supplier, they provide a condition monitoring device, so that for a belt, for example, it checks whether the cord is broken or not.
Okay.
So if it is broken, then it sends a signal to the controller. And so that's the most simplistic device and quite popular. It's a condition monitoring device for the belt. And so you similarly you need to have for the coated traction rope as well. And of course there are research going on where there are companies which are even providing magnetic flux leakage based condition monitoring device, which is more advanced, which is more accurate compared to this broken cord device. And there are techniques where you just count the cycles. For example, in US, TKE, they do the cycle counting. The controller counts the number of trips, and since the lifetime of the rope, the rope or the coated belt has been certified for a given lifetime, it keeps checking the number of trips, and based on that also you can take action. So there is a cycle counting technique. You can use a broken cord monitoring technique, and or you can also go for a magnetic flux leakage. So you have different types of products and techniques existing in the market. Yes, but you need to have a condition monitoring device. This is an additional thing compared to the conventional ropes.
Next question is from Mr. Prashant Shah. He wants to know about thickness of coating and life of coating.
If you talk about 8.1 CTP rope, um, the steel cable is around 6.4 to 6.5 So the remaining around like 1.5 is the overall thickness of the coating for 8.1 diameter rope. And the lifetime is like overall it is certified including the TPU. The entire rope has been certified, for example, for 4.8 million bending cycles. So the overall the rope is certified for 4.8 million cycles. So you don't need to worry that only the TPU may come out, or no, there's nothing like that. If provided the installation is proper, and there is no twist, the fleet angle is within the recommendation, the sheave geometry is maintained as per the specifications, and there is no reverse bending, you will get the lifetime that has been given because it's certified for that life.
Yeah, Prashant Shah is saying thanks for your answer. Our next question is anonymous. How is this different from ultra rope?
I think ultra rope is by Kone, I think. So ultra rope, I think it is by Kone, but if I understand correctly, I mean ultra rope is a carbon belt, I think. I'm not really sure. I think ultra rope is a belt. Uh, Similar, I mean, we don't really have any. As I'm not aware of the exact comparison between ultra rope and our belt or our coated traction rope, but the concept behind the ultra rope is also the same, to bring down the size of the motor, to increase the energy efficiency of the overall system, to make the elevator system more compact. So the rationale or the intention behind going for ultra rope is also same. So it's like it's a competitor, and it's like I don't really have the exact advantages. We don't have I don't have the comparison with me right now, but maybe I can look into this, I can check, and maybe I can get back to you.
Okay. Our next question is from Mr. Miraj Ahmad. In polymer coated rope, the main issue of plastic peeling will come. Have you considered it in?
No, I mean that's what we are trying to say. I mean, we have done the testing for those many bending cycle. For example, for 4.8 million bending cycles, it has been tested and it has been certified. So as long as the installation and maintenance is proper, you are going to get this life. And we have customers who are using this, and we have not faced this problem. And the rupture, the polymer coating comes out, I mean, one if and only if, let's say, I mean, you have a frequent emergency stop, there are frequent voltage fluctuations, due to which there is frequent emergency stop. I mean, unless and until you have those kind of an abnormal situation, where you have frequent e-stops, or the maintenance is not proper, or there is some twist in the rope during the installation. Otherwise, I mean, the polymer coating doesn't come out, both for the belt as well as for the rope, because it has been tested for those kind of cycles, continuous operation for 4.8 million bending cycles.
Even for these emergency stops, I think there is a, I mean, in the coated, rope or the coated belt certification, you can see it is also one of the tests that they do uh, for continuous emergency stops. Like they do continuous 8 stops, and they ensure that there is no damage to the belt, and then they would certify the product. So this is also something that we tested. But as Sriram said, like, if there are more frequent emergency stops, like just in a day, if there are 20, 30, I mean, that's a very abnormal kind of a situation that no one would really uh, can guarantee. But as long as you take care of the site conditions, there are no any dust or things. Even if there is once in a while there is an emergency stop, still the belt can survive. The
Yeah,
belt or the
exactly.
coated rope can survive.
Mr. Ahmed is saying thanks for the answer. I would like to be in touch with you in this project, and I am from a rope manufacturer, Usha Martin.
Yeah, sure, sure.
Next question is from Mr. Ernest Paul. What about rope stretch?
And I mean, the stretch will be less, because the stiffness of this coated traction rope is higher compared to your natural fiber core rope. And of course, compared to your full steel core rope, it could be less. But when you talk about a travel height of, let's say, 40-50 meter average travel height for the Indian market, compared to your natural fiber core rope, the stiffness of the coated traction rope is higher. So since the stiffness is higher, you are going to have low elongation, low stretch, and only the full steel core rope may have a better uh, stiffness compared to your coated traction rope or the belt. But as long as, let's say, for the belt, even up to 100 meter, there is no problem with the stretch. And for the coated traction rope, even up to 50 meter, 40 to 50 meter, you will not face any problem with respect to stretch.
He added one line saying that constructional stretch.
Constructional stretch, no, even that is also lower. I mean, what we try to see is a overall stretch. Even that is also lower compared to your fiber core rope. I mean, what we are trying to say here is your natural fiber core rope. And if you want, I mean, we can share the values. I mean, maybe we can get in touch with you later, and
It should be in our catalog,
in
right,
our
Sriram?
catalog we have mentioned. So
Yeah.
we can, or if you want, we can share even the values in the mail.
Moving on to our next question. Next question is anonymous. At what working temperature was it tested? Is it tested in Indian conditions? And do we have any spring effect observed in the cabin when it stopped?
A temperature, I mean, we can say that up to 50 degrees Celsius, the ambient temperature, you don't have any problem. So it can work. I mean, even from the low temperature -10 up to +50, there is no issue. And we have not faced any spring effect. I didn't exactly understand the question, but when it stops also, we didn't hear any spring effect or something. I mean, maybe
Are
I
they talking about the bouncing,
bouncing,
the
I'm
rope?
not
I
sure.
mean,
Yeah.
the cabin bouncing is what you generally see in the rope elevators, where
You can
the.
hear us, no?
Can you hear us?
Yes.
Sriram, can
Yes,
you hear me?
yes,
Yeah,
Yeah,
we
yes.
can hear you. Yeah.
it's okay. So I don't know, is it something related to the rope bouncing, when there's a people entering inside the cabin or
Yes, he's
exiting
saying
the cabin?
yes. It is about rope bouncing cable.
No, I mean, you will not have. That's what I mean, because the stiffness of this rope is higher compared to your fiber core rope. So in fact, you will have less bouncing and less low elongation, low stretch. It's quite stiff. The modulus of this rope is higher compared to your natural fiber core rope. I mean,
Yeah.
again, the point what we want to say is that, I mean, we are not trying to say this is a replacement or something, nothing like that. So the conventional rope, they have their own advantages. I mean, so it's just that we are trying to say that nowadays we have different suspension media. So if you want to really optimize the system, the suspension media plays a critical role. So during the system design, we can really look into the various performance parameters, various performance goals that we need to achieve, and we can select the optimum suspension media. So here, of course, we are just trying to create an awareness about the coated traction products. So we are giving the advantages of the coated traction products, but it's not like we are saying that, let's say, I mean, it will replace the conventional ropes completely. There's nothing like that. So it depends really on the application. So for some of the applications, your coated traction ropes performs much better compared to your conventional ropes. But let's say, case by case, if you talk about another application, maybe a conventional rope could perform better. It all depends on the cabin weight, the weight of the empty cabin, the travel height, and the configuration. The reverse bends, where the motor is located, whether you have any offset in the configuration. So we have to really look into all these factors, and we can select an optimum suspension media. I mean, that's the precise purpose of this presentation, where we want to throw some lights about the different suspension media.
Yes. Do we have any more questions by the attendees? I think so. That's all with the questions. I thank you once again, Sriram and Anand, for sharing the valuable insights about polymer traction coated ropes. And we truly appreciate your time and knowledge and contribution to educate the industry. And to the audience, thanks for joining us today. Your presence and participation means a lot, and it motivates us to like organizing such a webinar again and again. As a reminder, our session happens every Tuesday, and our next session will happen on 5th May. Thank you once again for joining us, and let's stay connected.
Yeah.
Thank you, Neelam. Thanks, everyone.
Thank
Bye.
you,
Thanks,
Anand. Thank
Neelam.
you, Sriram.
Thanks, Neelam, for the
Have
opportunity, and
a
thanks to the audience for your
Yeah.
time.
yes. Thank
So
you very much.
Neelam, just would like to ask you, like, if someone would like to connect to us,
Yeah,
how will
exactly.
they
You
be
can
able
share
to?
your contact details on a screen so that they can note it down.
Okay.
Okay.
Maybe you can just take a Word file and then type in your our email IDs, Sriram. That would be.
Yes.
You can see the screen, right? Anyway.
Yes, we can see your screen. Attendees, if you want to note down their contact details to connect them with them later, please go ahead.
Perfect.
Maybe you can zoom it a little bit.
A minute. Can you see?
Yes.
Yeah.
Yes.
All right. Thank you so much,
Great.
Neelam, and thanks once again, everyone, and wish you a wonderful rest of the day, guys.
Thank you. Thank
Thank
you,
you.
everyone, and
Thanks a
have a
lot.
good
Thank you.
evening.
Yeah.
Thank you.
Bye.
Yeah. Bye bye.
Bye, all of you. Bye.